This is R.D. Sharma solution, class 12, chapter 10, differentiability. Exercise is 10.1. Show that fx is equal to these two functions when x is less than equal to 3 and x is greater than 3. So there are two functions here and we have to show that they are differentiable at x equals 3. Also, we have to find f dash 3, that is the derivative of this function. So differentiability, continuity, all are related. So this is the point 3. Now before that 3 value, the function will be simply 12x minus 13. So this is an equation of a line. So this can be a line, you can make any line just to understand. And there will be 2x square plus 5, there is a function when x is greater than 3. So when you are below 3, you have to use the function 12x minus 13. When you are above, you have to use 2x square plus 5. Okay. So when the differentiability can be proven, the value will come and you don't have to differentiate again. That will be the value of the f dash 3. So left hand derivative and right hand derivative, that is what we are interested in. So we just write it by 3 minus 3 plus to indicate we are dealing with 3 minus left hand derivative, 3 plus right hand derivative. So you have limit extends to 3 minus. So you are going just backwards than 3. You are moving just forward to 3, that is x tends to 3 plus. So how do we check the differentiability? Fx minus fc by x minus c, limit extends to c. If this is a finite entity, this has certain value that can be comprehended, then that is what is differentiability. What is c here? In this case, c is 3. So we have fx minus f3 divided by x minus 3. Here also fx minus f3 divided by x minus 3. Same thing here. Only the fx and f3 has to be changed in both the cases. The fx when x is less than 3 is 12x minus 13 and f3 is what? Just see, x is less than equal to 3. So you have to use this function in both left hand derivative and right hand derivative. So 12 into 3, just put x as 3, 12 into 3 minus 13. So 36 minus 13, it is going to be 23. Just replace f3 by 23. X minus 3, so just you can keep it like that. So I'm not going to write this again, just assume that this is always there. That's why I show you the answer so that you know how to write it. Now you have fx minus f3. Now since x is greater than 3, you have to use 2x square plus 5. And since x is equal to 3, always you have to use 12x minus 13. So f3 means you have to replace x by 3 in 12x minus 13 that we already computed and that has come to be 23. So 2x square plus 5 minus 23 divided by x minus 3. So let us solve this one. It is going to be 13 plus 23 is 36. So it is going to be 12x. So this is going to be 36. 12x minus 36. And if you take 12 common, it will be x minus 3. X minus 3 is always in the denominator. So you have 12 as the left hand derivative. This is your left hand derivative, okay? Now coming to the right hand derivative, what do you see here? This 5 minus 23 is negative 18. 2x square minus 18, just take 2 common, x square minus 9 it will be. And divided by x minus 3. So this x square minus 9 can be written as x square minus 3 square. You can use a square minus b square formula as a minus b, a plus b. So it will be x minus 3, x plus 3. X minus 3 is already in the denominator. Okay. So you already have a denominator. You can just cancel these two out. 2 into x plus 3, it will be there. Now since it is continued, limit extends to 3 now. Replace x by 3. So 3 plus 3 is 6. 6 into 2 is again 12. See, limit has changed now. Since we replaced fx by 2x square plus 5, now it is x tends to 3. So both the ways, left hand derivative and right hand derivative we computed and that has come to be 12. What is f dash 3? It is just the left hand derivative or right hand derivative. You can take any of it because they are eventually equal. This is 12. Answer is 12. Show that the function f defined as follows is continuous at x equals 2 but not differentiable at these. So you have to show it to be continuous, and you also have to show that in spite of being continuous, it is not differentiable. Alright? So you just see the variation. These intervals are very important. And we always check in between where the function is changing. From 0 to 1, it is 3x minus 2. You have to use this function. Between 0 and 1, you have to use a. I'm just assigning it to be a. Second function, let us say it is b. So between 1 and 2, you have to use this. And above 2, you have to use the function 5x minus 4, c function. So the continuity first to be computed. So this continuity, see, left hand limit, right hand limit, and if LHL, RHL is equal to the value of the function at that value which is given as 2 here, that we will see. So LHL, RHL, we have the point of contention or point of to be checked is x equals 2. So x equals 2 minus h on the left hand limit, x equals 2 plus h on the right hand limit. Okay, but please see, when you go above 1, you have to, this below 2, that is b function you have to use. So 2 and 2 minus h whole square, because I am replacing x by 2 minus h, and then again 2 minus h. So 2, you can just open it. See, you have to do it like that. You have to open it properly and then put h equal to 0. Not like this. I know because what I am getting, so I just did it. So the final thing will come as 6. And you have to write all this. See, I'm just skipping it because on the left hand side I showed you the answer, because you have to write like that. Right hand limit, you're going above 2. When you're going above 2, it is going to be 5x minus 3. So in place of x, write 2 plus h minus 4. So this h goes 0. 10 minus 4 is going to be 6. So you have to show that the function is defined and this is continuous at x equals 2. So left hand limit, right hand limit are equal. And what is the value of the function at 2? Where 2 is equal? See, x is equal to 2, less than or equal to 2. So you have to use 2x square minus x function. 2 into 2 square minus 2, 2 into 4, 8, 8 minus 2 is 6. So what they have asked, we have done it. LHL, RHL and value of the function at this 2 is equal. So this is about continuity. Now next thing is the differentiability. So in order to find out the differentiability, we have to take a step ahead. So what is the step ahead? Please remember, the LHL and RHL we have found out. Here we are going to find out the LHD and RHD, left hand derivative and right hand derivative. Again at the point 2. So left hand derivative, it will be limit x tends to 2 minus, just to show that we are going a bit backwards. Limit x tends to 2 plus, just to show that we are just going a bit forward. So fx minus f2 divided by x minus 2. This is going to be left hand derivative x minus 2. And right hand derivative is fx minus f2 divided by x minus 2. Okay. So what we have got is fx minus f2 divided by x minus 2. So I am doing the left hand derivative first and then we'll go to the right hand derivative. Now you see, when we computed for the continuity, left hand limit, so fx was what? Is 6. And what is f2? Again 6. 6 minus 6. So you are going to get a certain different result here. But we have to do it differently. We have to write x as 2 minus h here. So see, fx was already, we computed just now, is 6. f2 is 6. So we cannot do it like that because it will be 0 ultimately. We have to take proper steps so that the denominator gets cancelled. Okay, so 2 into 2 minus h whole square. And because we are going below 2, so you have to use 2x square minus x function. In the x, you have to write 2 minus h. So I have used 2 minus h in 2x square minus x. And of course, you have f2 as 6. So minus 6. So what do you get in the numerator? I am just opening it. a minus b whole square, and then this is minus 2 minus h minus 6. Just open this, and denominator is negative h. We'll just use this negative h just now. So 8 plus 2h square minus 8h minus 2 minus h minus 6. Now what do you see here? See, 8 is there, minus 2 is there, minus 6 is there. So 8 minus 8 is 0. So all these three will vanish. You will get 2h square minus 8h minus h. Now take h common from here. So you will get 2h minus 8 and minus, this is going to be 1, minus 1. And denominator is what? Minus h. So h gets cancelled. Okay. So minus 2h. And this is going to be, it's going to be, see, minus 2h plus 7. I'll just change it, okay. It is going to be only 7 because when you apply the limit, it is going to be 7. There is slight change here. It's going to be 7, okay, because h gets cancelled. It was minus 2 plus h. Now same thing we are going to do for the right hand derivative. So limit x tends to 2 plus, that is x equals 2 plus h, you have to write. Fx minus f2 divided by x minus 2, same thing. Fx, so x equals 2 plus h. Now you have to use the function fx minus 5x minus 4. So 5 into 2 plus h minus 4 minus 6. Same thing here, just open this. So it is going to be, we just open it, 5 2s are 10 plus 5h minus 4 minus 6. So minus 4 minus 6 is negative 10. Negative 10, 10 cancels, you have 5h. And in the denominator, what do you get? X you have to replace by 2 plus h. So 2 plus h minus 2, this 2 gets cancelled, h it is, h gets cancelled, you have a 5. So when you apply, you don't have to apply the limit because it has a constant. So left hand limit was 7, right hand limit is 5. So left hand limit is not matching with right hand limit. That means this function is not differentiable at x equals 2. Okay. Now discuss the continuity and differentiability of this fx equals this. This in the continuity discussion we have done it a lot. Okay. So minus 1 to 2, this is whole C interval. So you have to check in the phases in different partitions. So let me just make it like this. You have a 0 here, you have a negative 1 here, 1 and 2. So negative 1 and 2 are not of that importance right now. 0 and 1 is important because it is between minus 1 and 2, and at 0 and 1 the function changes. So mod x is x when x is greater than 0. It is going to be negative x when x is less than 0. That we already know. What is mod x minus 1? Mod x minus 1? See, it means x minus 1 equals to 0, so x equals 1, the point is 1. So below 1 it is going to be negative, and above 1 it is going to be positive. So x minus 1 for x greater than 1, and when x is less than 1 it is going to be negative of x minus 1. So you can write this negative of x minus 1 like this, minus x minus 1, so minus x plus 1. You can always write it as 1 minus x, or it can be minus x plus 1, whichever way you want. Okay. Now we will make the intervals. Minus 1 to 0 what is happening, 0 to 1 what is happening, and 1 to 2 what is happening. For whole function, mod x plus mod x minus 1. So fx in the interval of minus 1 to 0, that is the first interval, what do you get? This mod x, because it is 0, less than 0, so it is going to be negative x. Negative x. And since you are still below 1, it is going to be negative x minus 1. Just check what we are dealing with. We are between minus 1 and 0. So you are below 0. And below 1, mod x minus 1 is negative. Below 1 and below 0, mod x is negative. So just write negative, negative. So minus 2x plus 1 for minus 1 to 0. I hope you got the idea. Now it's the second interval. Fx, the second interval is 0 to 1. So 0 to 1 is the second interval. Now when you go above 0, mod x will become positive. So it will be positive x. But still the mod x minus 1 is going to be negative because you are still below 1. You are above 0 but you are still below 1. So you have to again use this 1 minus x. X gets cancelled, you get a constant 1. Alright. Now coming to the third interval, fx, 1 and 2. So when you are between 1 and 2, this both are positive. You are above 1. So x plus x minus 1, this is going to be 2x minus 1. Now this 3 we are going to use in this solution of this question. Because I am going to take you to the continuity first and then the differentiability. If it is continuous, it may be differentiable, it may not be differentiable. But if it is differentiable, it should be definitely continuous. Right? So there is no point in checking the differentiability if you have to check the continuity, because differentiability doesn't point to continuity. Differentiability point to continuity, but continuity doesn't point to differentiability. It may not. So just watch very carefully. I am going to do it. As I said, we have minus 1 to 2. We have 2 points, 0 and 1. That is where we are going to check. Because x becomes 0 and x minus 1 also becomes 0 in between. So LHL and RHL I am going to use at x equals to 0. So what you can do is you can put always 0 minus h on the left hand side, 0 plus h on the right hand side. That's so always you can do. So 0 minus will write. You can always write 0 plus h, but I am going to write 0 plus because we already know what is going to come because we have already solved it. Right? So x says 0 minus h. 0. What are you going to use? See, I already told you that in minus 1, 0, this is 1 and 2. So when you are below 0, what are you going to use? That is in the interval minus 1 and 0, what did we get? Minus 2x plus 1. This one. Because below 0. So minus 2x plus 1. Now apply the limit. Limit x tends to 0. So this minus 2 into 0 will be 0. You get a 1. This is going to be 0. You only get 1. What about the right hand limit? You are going above 0. When you go above 0, that is between 0 and 1, you are going to use 1. That was a constant. So there is no point in applying the limit because it is already a constant. So left hand limit and right hand limit, they have become equal. LHL and RHL are equal. So that means x equals to 0, it is continuous. Now we are going to check at x equals to 1. Same thing we are going to do. Okay. When you are going to check at x 1, LHL will be x tends to 1 minus, RHL will be equal to x tends to 1 plus. So 1 minus h, 1 plus h you can always use. I am not going to use it because already we have solved it. We know what are the values in these intervals. These already 3 things. I explained it to you. So we don't have to go for 1 minus h, 1 plus h. The situation or the way of solving will be same. It will be same. Okay. So when we go in the interval 0 to 1, we know it is 1. When we are above 1 plus, that is 1 to 2, the interval 2x minus 1. Apply the limit here, x tends to 1. Because you have to check for x equals 1. So 2 into 1 minus 1, that is going to be 1. So you have 1 and 1 on the LHL and RHL for the x equals to 1. So what do you get? It is continuous. Continuity has been checked. Now from minus 1 to 2, you have 0 and 1. You have already checked continuity at 0 and 1. So the limit is existing. The continuity is favorable to us in this case. What about the differentiability? So when we go to differentiability, fx we know already, minus 2x plus 1. So what will be f dash x? That is the differentiation. You already know the differentiation by now. In the interval minus 1 to 0, we have already found out fx. What is f dash x? When you differentiate it, 1 will be 0 and x will be 1. So minus 2 it will be. Now f dash x in the interval 0 to 1, what will be there? What will be it? It was 1. So when we differentiate 1, it is going to be 0. You have to take the differential of this, what we have found earlier for the continuity. Now this is 2x minus 1, so what will be f dash x? F dash x for 2x minus 1 is going to be in between 1 and 2. 1 is 0, and when you differentiate 2x, it is going to be 2 only. So minus 2, 0, 2. Now you don't have to go for all that thing, x tends to 0 minus 0 plus 1 minus 1 plus y. Because if you check it at x equals to 0, when you go to left hand limit, 0 minus 0 plus, why to apply the limit? Because it is already a constant. F dash x is already constant. So when you go, just backwards of 0, minus 1 to 0, you are trying to find out. It is going to be negative 2. It is a constant. You can apply the limit. You can always do that. This 0 minus h and 0 plus h. All I explained you earlier. But it is not required here. Minus 2 is constant. So just write minus 2. When you go from 0 to 1, it is going to be 0 because it is already a constant f dash x. I already told you. When you go just backwards or below this 1, it is going to be 0. Above it is 2. Minus 2 is not equal to 0. That is left hand derivative and right hand derivative not equal for x equals 0. This is not RHLR. This is just the derivative basically. So the left hand limit and right hand limit for the derivative, they are not equal at x equals 0 and x at x equals 1. Okay. Okay, this question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.